Hello, welcome to the video walkthrough for the Key Assessment 3. Now those eagle-eyed amongst you may look at that and say, well, 80 marks and 90 minutes, and for the vocational students that's not what you got. You were doing 55 marks in 60 minutes, and that's because you weren't doing the full paper. Okay, so this video will cover all of it with a pause at the relevant point for those to stop if they need to. Okay, so these will be our worked answers as we go through. Well, my writing's terrible, I know. Okay, so hopefully you filled in the blurb about any extra time you may have, anything like that. Moving on. Now, sequences for question 1. And we have got draw pattern 4, and we can see that basically our corners are going to stay the same. So we've got across there, but what's happened here is that's increased. So we're going to end up with 3 crosses, and let's face it, we don't really want to be shading completely black, but please do make some attempt at shading. Just makes it that bit clearer for us, and it means that it is clear as to what we've done. Okay. Now here it says how many black squares would there be in pattern 7. Okay. So what we can do, we can see we've started off here, we've got 3. Here we've got 4, and here we've got 5. Now all we can see there, pattern 1 we've got 3, pattern 2 is 4, 3 is 5, so it's 2 more, isn't it? So that would be pattern 7, it'd just be 7 plus 2, so we would end up with 9. Okay, that will do us for that. Question 2, line AB is on a grid, and A down to B, and they want the coordinates of B, so they want this one here. So of course, it's along the corridor, up the stairs, so it should be 2, 1. And part B, write down the coordinate of the midpoint of the line AB, so they want the middle of this line, okay? So if we look at this, it goes from 2 to 8, so it's gone up by 6, so if we go up by 3, we go 1, 2, 3, and we can see there that is our midpoint, and we can see the distance there, and again the coordinates along the corridor, up the stairs, we will have 5 and 4 in that order. Okay. Question 3, and it's all to do with basically all possible options. So we've got the main meal, so the pasta, the spaghetti or pen, and then we've got the sauce, cheese, bolognese or tomato, and the combinations. So they've done the first one for us, they've done spaghetti with cheese, so we can then have spaghetti with bolognese or spaghetti with tomato, and then the other one is going to be the pen with cheese, pen with bolognese, and the pen with tomato. That's all we want. And 2 marks for that. It says which fraction of the possible pasta dishes do not have a cheese sauce. Okay, so we don't want this one, and we don't want this one, so that leaves us with 1, 2, 3, 4. So it's 4 out of 6. Okay, it could be simplified down to 2 over 3, but I'd still want to see that original fraction if you do so. Okay, so question 4, number machines. We start off with our input. We have 2 processes, so we times by 5, take away 3, and we get our output. Now, I'm going to leave those blank for now and do the working on here, just because I'm going to need it more for the second part. Okay, so if the input is 6, first thing we're going to do is times it by 5, and then I'm going to take away 3, and that will give me my answer. So 6 times 5 gives me 30, take away 3, I'm left with 27. So that is my answer for part 1. But for this one, the input, we need to find that, and the output is 47. So this time I'm going to use it. I'm going to put my 47 there, and I need to go backwards now. So to go backwards, instead of taking away 3, I'm going to add 3. 47 plus 3 is going to give me 50, and then instead of multiplying by 5, I'm going to divide by 5, which means, so we've got 50 divided by 5, and that leaves me with 10, and that goes there. Okay, And then the last one, our missing value is here. So if I deal with the first bit, 20 plus 4, I've now got 24. And I need to do something to 24. That gets me to 3. Okay. I'm just going to give you a couple of options on this one. I could do 24 divided by 3. Sorry, divided by 8, which will give me 3. Or I could just do 24 take away 21, which will give me 3. Either one will do. They haven't specified a symbol there, so we could divide by 8 or we could take away 21. It'll get us to where we need to be. Okay. So on to question 5, and we have got some fractions, decimals and percentages. And I've seen this a few times already this week. If we know we've got 25%, change that into a fraction. What we can do is we can just put 25 over 100. Now they haven't said it, they have to be in the simplest form. So as far as I'm concerned, that's fine. But of course we can simplify that down, and it's also the same as 1/4. 7 over 10 or 70% is going to give us 0.7. And 3/5 or 0.6, again we times that by 100, we know we're going to get 60% there. Okay. Now if we look at these, which percentage of the grid is shaded, and we look at all those squares, and simple way is we can count up, and there's 5 across and it's by 4, so that gives us 20 squares, and the shaded is 4 times 4 to give us 16. And then we can just times that by 5 to make it out of 100. And 16 times 5, well, let's face it, we've got them, let's use them. So let's switch it on. And all we're going to do, 16 times 5 gives me 80. Now that's 80 over 100. So we know that is 80 out of 100, so that's our percentage, 80%. Question 6, unusual question, but which metric unit would be most suitable for each measurement? And you think a length of a sports pitch. Would you really want to measure it in centimetres? Too many of them. Kilometres, we're going to end up in decimals, aren't we? We're going to end up too less. So I would say definitely metres there. Width of a TV. Well, let's face it, I know some televisions are getting big these days, but realistically we need to be in centimetres, okay? Definitely not kilometres. And the distance travelled by a train. Again, we could measure in all 3, but most suitable, we're going to go kilometres there, okay? Question 7, all to do with mobile phone plans. And part A says show that the total cost of plan A for 36 months is 904. So they're saying that is the plan. We've just got to get to that, find a way to get to it. So we're starting off with 400, and then we're going to add, and it's £14 per month for 36 months, so 14 times 36, okay? So if I type that in exactly as it looks, got my 400 plus 14 times 36, I get 904, okay? And that's £904. Matches, doesn't it? Now, just in case you do it slightly different, if we just did 14, put the camera there, so 14 times 36, that gives me 504, which of course we can add to our 400, okay? So I'll just put that in brackets there. And then we're going to end up with the same amount, okay? So different methods, same approach, okay? Now, during the sale, the total cost of Plan B is reduced by 10%, and then they want to find out which one is cheaper, and it says show working. So it's not enough just to tick a box; we need the plan. Okay. So again, 2 different ways. I can look at this. I've got £30 a month for 36 months with a free phone. So I can do 30 times 36. Again, let's use them, we've got them. So 30 times 36, which gives me 1080. And then I can reduce that by 10%, okay? Now 10% is 108. We can take that away from our working and we will get our answer. But if we're reducing by 10%, that also means we've got 90% left. So let's take our 1080 and I'm going to times it by 0.9 for the 90%, and that gives me 972, okay? So we'll put that there, 972. The other way is to reduce the 30 by 10%. 10% of 30 is 3. So that means we're going to be doing £27 a month, and 27 times 36 gives us, you guessed it, 972. Okay, either way, as long as we've got our price. And of course, we can still see that our original price of 904 is still cheaper than the reduced price, so we are looking at plan A ticked. Okay. Question 8. Money and ice cream. What a mix. So we know that one ice cream costs £2.10. We need 2 ice creams and 3 ice lollies to get to there, okay? So we can do, well, 2 ice creams, 2 times £2.10 is going to give me £4.20. If I take that away from the original, so I've now got £9.72, I'm going to take away by £4.20, and that will leave me with the cost of the 3 ice lollies, okay? So £9.72, take away £4.20, and we are left with, and again, it came up with it in a fractional form. Remember, new calculators, new process, no SD button. Press format at the bottom, and then we just scroll down to decimal. And there we have our answers for £5.52. And that £5.52 needs to be split now between the 3 ice lollies. So we are going to do £5.52 divided by 3. And again, we could use a calculator. Let's go through it. 3 goes into 5 once, and then we've got 2 remainder. And 3 goes into 25, and it goes in 8 times, and it's got 1 remainder, and it goes in there 4 times. So it's £1.84 for that, okay? You can work it out using algebra. We can say that we could say we had 2 ice creams. So if we had C for the ice creams and L for the lollies, so 2C plus 3L give us £9.72, and we can work out. We can substitute the cost of the lollies. It's the same process. It's just a different way of showing it. Okay. Question 9. The cube of a whole number is a 2-digit number. We want the smallest and the largest. So a cube, now if we look at our cube numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Now, it has to be a 2-digit number, so we can roll that one out, and we can roll off the 1 and the 8, because they, again, 2-digit number. So we are left with 27 and 64. So we now want the smallest number that could have been cubed, and we said 3 cubed gave us 27, so that's 3 there. And the largest number, well, 4 cubed gave us 64, and that's what they were after there for that one. Okay, I know that caught a few out with that. And then nice simple calculator question, which has the larger value, 0.6 squared or 0.6 cubed, and it says give a reason for your answer. So what we can do is we can have a look at what each of them is as a decimal. So if I clear all of those, I've got 0.6 squared, and again I need to change that, so change format and down to a decimal. I've got 0.36. okay, so this one is 0.36, and then the next one I'm going to do similar, but 0.6. Now there's no cube button as such on these like there is on the old Casio, so we press that one and we can put the 3 in, and again I need to change the format into a decimal, and I've got 0.216, and we can see that this is bigger, so it will be that one. Another reason for it, which I have seen as well, is because we're multiplying it by itself, we're multiplying by something less than 1. So the more times we do it, the smaller our answer is going to be. So the cubed will always be the smaller version than the squared for that. Question 10. Yeah, this one was lovely. £3.42 is paid using the smallest possible number of coins, and we want the modal value. Now this word always upsets people when they see it. Modal value. Basically it's the mode. That's what we're after. And you must show your working. So we can't just pick a coin out at random and say, yeah, it's that one. We need to show how we could get it. So £3.42. Now there's loads of different ways. I saw someone decide they would have 342 pennies, but that would definitely not be the smallest number of coins. So we need to think of the largest denomination of coins we can use. So if I put a list on here, so we can have £2 coins, then £1, 50 pence, 20 pence, 10 pence, 5 pence, 2 pence, and then 1 pence. Okay. So that's a list of coins. Now, first one I'm going to tick off. We need one of those, one £2 coin, and then we need £1 coin. There's our £3 already. 40 pence, easiest way is to do 2 20 pences, and then the 2 pence is just one of those. And straight away I can see my modal value there is 20 pence. And then we've got median, the middle number. So what we need is an extra number to put into the list. So the median numbers is now 9, and we can work with that. Okay, we work out the extra number, because if we look at those, I'm going to leave a big space in between. So we've got 5 as our first, got 4 as our first, then 5, then we've got 8, then we've got 13, and then we've got 17. Okay, nice big gaps between them. And at the moment we know, we count down, we got, that's 8 at the minute, but we need it to be 9. But we're only adding one number, so that means 9 must be in the middle of 2 numbers. And all it is, we know there's one different there, so we go 1 up, 1 there. So that, our missing value must be 10. Now, restaurant and plates. Restaurant has 30 tables, and he's going to buy 4 plates for each table, plus an extra 60% for spares. So straight off, we know 30 tables, 4 plates per table. 30 times 4 is going to give me 120 plates. Now, we need an extra 60%. So 10% of 120 will be 12. And then to get to our 60%, we're going to multiply by 6. And 12 times by 6 is going to give me 72. And I can add that on now, so I'll end up with my 192. There is another way, of course, because we know the original amount of plates will be the 100% plus another 60%, so wereafter we will end up with 160%, and that as a decimal we would end up with 1.6. So if we times that by the 120. We do that on our calculator. 1.6 times 120, and we get our 192. So using a multiplier, remember the 1 is the original amount plus the 0.6, which is the 60%, and that will give us 192 as well. So a couple of different methods, but I'd imagine most people have gone for that method of working out the 60% and adding it on. Okay. Question 12, scatter graph. Always fun things. And first off, to me, it's asking basically write down 2 mistakes they've made on this one. Okay. And the first one is the most obvious, and it's the line of best fit. Because with a scatter graph, we know they're not joining up the coordinates. It's about the best fit for those coordinates. Okay, so I would expect it to be something along these lines. Okay, and again, not perfect, but something along that line in the middle. That's where I'd expect it to be. So as far as I'm concerned, the first mistake, so line of best fit is in the wrong place. And it's basically we're after something along those lines. So we could say line of best fit is in the wrong place, or the line of best fit it doesn't pass through the middle of the coordinates. We're looking for anything along those lines, aren't we? Okay. For the second part of it, we need to be a bit more technical now. And what we're looking at, first off, if we look at our scale. So we go from 0 to 500 and up to 1,000. So we've gone up by £500, but then we suddenly jump to 5,000, then 10,000. So we've gone up by 500 quid and then by £5,000. So our scale on the y-axis isn't even. So y-axis scale, in brackets value, just in case that's what you've used, doesn't go up evenly. Because we know that these steps should be equal. They've done it here, they've gone up in periods of 2 years. There is another mistake on there, they're the 2 obvious ones. Okay. The last one is to do with this. For a 7-year-old car, it should be on 10,000. And when we look at 7, it's actually on what looks like somewhere around 9,000 on that one. Okay, so that plot is wrong. So there you go. We could say the plot for a 7-year-old car is incorrect. So I've listed 3. We only needed 2. And of course, you know, I defy anyone to read that clearly. When we're doing these things, we need to make sure our handwriting is clear, don't we? Okay. Because if the person marking it can't read it, you won't get the mark. So be careful. Question 13. So we've got a rectangle and a triangle are drawn on a square grid, and we want to ratio area of rectangle to the area of triangle. Now, the one thing they haven't mentioned here are any measurements, any units. Normally, it would say on a centimetre grid, but it hasn't here. So we don't know whether the centimetres or anything. All we do is we deal with what we've got in front of us. So when we look at this, so the rectangle is base times height. So our base is 1, 2, 3, 4, 5, and our height is 4. So 5 times 4 is going to give us 20. And then the triangle, we've got a base of 1, 2, 3, and the height is 1, 2, 3, 4, 5, 6. 3 times 6 gives me 18, and I halve it because it's a triangle. So we do 3 times 6 divided by 2, which gives me 9. And they're the 2, because when we do 20 to 9, we can't simplify that. That's all they were after, and they didn't ask us to simplify either. Okay, so that's all it was. Question 14. and it's to do with probability, and again it's given in a decimal form, so it must add up to 1. So if we look at this first one, green, the probability of green is 2 times the probability of blue. So that means we are doing 2 times 0.26, which gives me 0.52. And of course, because it's probability in this form, they must all add up to 1. So what we can do, we can add those all up and take them away, or we can take them away individually. Either way, we should end up with 0.12 for that. Okay. Now I've skipped. I've not shown you the calculation. We could, as I say, we could add those 3 together and take it away from the 1 to find our missing 1, or we could start with the 1 and take away each in turn. We will still end up at the same point. And then the second part, there are 300 cards in the box. How many cards are not blue? Now the probability of it being blue is 0.26. So if I do 1 take away 0.26, and we will use it for this just because we can, 1 take away 0.26, and we get, again, we get a fraction, so format down to decimal, and we get 0.74. And that's now at decimal, we can use that as our multiplier. So we can do 300 times 0.74. And let's clear that off. So we do exactly as we said, 300 times 0.74, and that gives me 222, and that is my answer. The mistakes I saw here were sometimes people worked out the blue. Now if you work out the blue, you can just take that away from 300. That's just as easy a method, okay? Because we want not blue. But if you're going to do it that way, be careful that you don't then put that as your answer, because it was just for the ones that were not blue. Now, the language of a question and the way that words mean different things. So it tells us that A and B are congruent triangles, and they haven't shown any triangles. And we're used to triangles being equilateral, isosceles, scalene and right angle, but none of them were mentioned as congruent at the time. Where congruent comes in, it's between congruent and similarity, okay? Similar triangles are triangles that have the same angles but can be bigger or smaller. But congruent triangles will be identical triangles. They may be rotated, they may even be flipped, but they will have the same angles and the same sides. So first one, A's angles are the same as B's angles. Yes, always true. A is an enlargement of B with a scale factor greater than 1. No, because again, if it was different size, it would be a similar triangle, not congruent. So that is never true. And A's sides are the same length as B's sides. Again, congruent means they are the same triangle, same angles, same sides. So that is that. Okay. And question 16. Oh, did this cause some fun? Don't we just love when they put algebra into geometry? Now, the important thing here is it's an equilateral triangle. And it says all measurements are made in centimetres, even though, well, it doesn't look like centimetres to us, does it? And it says work out the value of the perimeter of the triangle. So we don't want it in algebraic form, we want an actual answer. So, here's the trick. It's an equilateral triangle. All 3 sides are equal. They've only given us 2, but they're telling us that that is equal to that. So let's show that. We've got 5x minus 1 is equal to 3x plus 7. And we've got an equation, because it's got an equal sign in the middle, but we've got an unknown on both sides. So first thing I need to do is get rid of either the 5x or the 3x. And the 3x is the simplest, so I'm going to take away 3x, but I have to do the same on this side. So that means 5x take away 3x leaves me with 2x minus 1. 3x minus 3x, they've gone, so we're just left with 7 on that side. It's a positive 7. No, didn't put my 1 in there. There, now it makes more sense. We can now do the next step. It's now a two-step equation. So I need to add 1 on both sides. So now I know that 2x is now equal to 8, and it's 2 times x, so I'm going to divide both by 2, and that means that x is equal to 4. So far so good. And now we can substitute that into each one of those, okay? Because if we're saying x is 4, what we're doing here is we're doing 5 times 4, take away 1, which gives us 19. If I did it on this side, same approach. 3 times 4, which is 12, plus 7, we get 19. So we're proving that our sides are 19 centimetres. And of course, perimeter, we add all the sides. So what we're doing, well, we can do 19 plus 19 plus 19, or we can do 19 times 3. Either way, we're going to end up with 57 for those. Doesn't matter which method we use, we end up with 57, and that is our answer, 57 centimetres. Hope it's been useful so far. Like I say, for the vocational learners, you're done at this point, and for the full-timers and the adults, we're going to carry on in a moment and finish the rest of the paper. Right, so if you're doing the full paper, this is the rest of the script for us. So we start off with some relative frequency, and here we need to know, basically, we work out, we can add those together, find out how many throws in total. In this case, there are 400 throws. But we need to work out how many are heads, because we need to work out the relative frequency of heads for all 400 throws. So we know 140 of these are heads, and we know 0.7 of those are heads as well. So all we do that times that. So again, back with our Casio, our wonderful new Casio, so hopefully we can see that okay. I'll double check as we go through. So we did 180 throws, and we multiply that by the probability, which is 0.7, and that gives us 126. So we've already got 140 there. So when we add those together, we get 266. So relative frequency for these, we could say, is 266 out of 400, or we could simplify it down, which comes down to, I'll put it down there, as or 133 over 200. Well, what we can do, of course, is change it to a decimal, and we could do that in this fashion. So we had 266 over 400, which gives us, when we change that, use the format button to change it to a decimal, and we get 0.665. Okay, and that, any one of those, I'll put all there, so either one of those will get you the marks. And then it asks which results would give the best estimate of the probability of heads. Would it be Sid's 180 throws, Zach's 220, or all 400? And the simple answer there, well, they say give a reason for your answer. Simple answer is all 400, because it's the largest sample, okay? If you want accurate data, you need the largest sample that you can from it. In this case, we can just say because it is the largest sample or amount or anything along those lines, okay? That's question 17 done. And we can move on. So a little bit to do with pie charts now. It gives us, so pie chart represents the results of matches played by a team. So we've got won, lost and drew. And we know that 60 of the matches were won. Okay. So here we've got half of it, haven't we? So if 60 is half, that means the whole, the 360, would be double that. So that would give us 120 matches played. And we want to work out how many would a draw. And we can see there 48 degrees. And now that's 48 degrees out of our 360. So show that as a fraction. We can do 48 over 360. And then we can times it by the total. Times that by 120. And that should give us our answer then. So again, back to our calculator. Try and move that so we don't get the glare. There we go. I think it's about right. So I'll move the paper over. So you can see what we're doing. So it's just 48 over 360. Don't forget to move that to the side. And then we're going to times it by the amount, which is 120. And that gives us an answer of 16. So that means they drew 16 of their games. So 16 out of the 120. Now, scale diagrams. So on this one, it tells us that scale is 1 to 300,000, and it's on a centimetre grid. So each one of these squares is a square centimetre. So it's when it says work out the actual distance from B to C, we're going from B to C in that direction. So we've got 1, 2, 3, 4, 5.5 squares. Okay. So we're just going to do, if we think our scale is 1 to 300,000, for every 1 centimetre, we've got 300,000 centimetres. So we can do 5.5 times 300,000. As we know, that's going to give us a big number. And we get 1,650,000. And at that moment, this is in centimetres. So we need to change this. So we need to work that through. Now, it says give your answer in kilometres. So we've got to change. We need to get down to kilometres. We don't go straight. You probably could if you know the conversion ratio, but to go straight from centimetres to kilometres is a big ask. So basically, what we need to do is go to meters first. So centimetres into meters. We know there's 100 centimetres in a metre. So what we're going to do there, we're going to divide that by 100. So my answer divided by 100, and that gives me 16,500. That's 16,500 metres. And by this point, again, some of you who are good with your conversions will already know the answer to this one. But of course, metres to kilometres, there's 1,000 metres in kilometres, so we're going to divide that by 1,000. So again, take our answer, divide by 1,000, and we get the decimal, change it over, 16.5. So it's 16.5 kilometres, and there's your marks. So working with the measurements, working with the scale, and then converting that down, and that's 4 marks for that one. Now, I'm not going to get rid of this page just yet, because part B is over here, and it says A is northwest of B, and we write down the bearing of A from B. So if I look at this, I'm going to use my protractor as a straight edge as well, because I can. So we're doing A from B. So if I draw that line, I'm going in that direction. So bearings, we always measure from north. So we'd always measure from that line, but we'd always measure clockwise. Now the thing is, it's on a centimetre grid, it's on a square grid already. So if we look at this as use this as a guide. We've got north, east, south and west. And we know from 0 degrees here, east is 90, south is 180 degrees, and west is 270. But this is northwest, so this is halfway between So we know these are in groups of 90. So half of 90 is 45. When we add that on to 270, we get 315. So a bearing of 315 degrees. Now remember, with bearings, it's always from north, always clockwise, and the answer is always in 3 digits. Okay? Do not measure anti-clockwise. So there's our answer, 315 degrees, which I'll now put on to that page. 315. Looks like I put a decimal point there. Okay. They've already got the degree sign on there, so I've not put it on the answer. So now we're on to, we've got a linear sequence that has second term of 7 and a fifth term of 22. Now it's a linear sequence, so the easiest thing I'm going to do is I'm just going to write my sequence. I'm going to do it down here where I've got extra space. So we, first term, second, third term, fourth term, and the fifth term. So the second term is 7, and the fifth term is 22. And when I look there, we've gone up, we've added 15. Well, what we've actually done, we've gone up 1, 2, 3 spaces, haven't we? So 15 divided by 3, that gives us 5. So we're adding 5 each time. Now that means we've got 5n, 5 times the number of the term. Now, to work out the rest of it, we go back, I'll come back up to there, we normally go back to the 0 term. And we basically, when we go in the opposite direction, we do the opposite thing. And of course, what they've done to trick us is, we haven't got the first term. So now I've got to take away 5. So 7 take away 5 leaves me with a positive 2. And then I'm going to take away another 5 to get me to the 0 term. And 2 take away 5 gives me -3. And that is the second part. Okay. Hope that makes sense. So now we're dealing with money. Ali, B and Cal each have an amount of money. We know Cal's amount, so Cal has £420. Cal's amount is 3/4 of B's, and Ali's amount to B's amount is 7 to 10, a ratio of 7 to 10. So, since that they're looking at ratio, I'm going to set it out as 1. So we've got Ali, B, and Cal. And we know that Cal has 420. Okay, now, it tells us that Cal's amount is 3/4 of B's amount. So this is 3/4 of that. Okay. So we need to do a reverse percentage. So if we know that is 3/4 of something, we divide it by 3 and then we times it by 4 to get the full amount. So we can do 320 divided by 3. Sorry, did I say 320? Because I've got 3 on my mind there. 420, that's how easy it is to make a mistake. 420 divided by 3, and then we're going to times that by 4. And that will give me, well, let's do it on there. So set it out exactly as we've done, 420 over 3, move it to the side, and then we can times that by 4, and we get 560. So that means B gets £560, and now we can work out Ali's. Now, Ali's amount, so the ratio of Ali's amount to B's amount is 7 to 10. Okay, so for every £10 that B's got, Ali's only getting 7. So the simple way to do that is we can take that 560. We can divide it by 10 to get one part of it, and then times it by 7. And again, use a calculator. We've got them there. So 560 divided by 10, move it to the side, and then we can times that by 7. and we get 392. So that's Ali's amount, 392, and that is the one they want. They want how much money Ali has, so it's 392. Be careful with that, make sure you put only the one. If you put the full ratio there on the answer line, you will lose marks. Okay. So the Venn diagram is a little bit sneakier, because what they've done, they've given us most of it, but they've missed out there. And all they've told us, the probability of it being B is a half. And that's a half of, basically, that's a half of all that we've got. Now, what I'm actually going to do there, because the 20 is already there, and we've got that, we know the 20 matches to this one and to this one, I'm going to disregard it for the moment, okay? So we have got 30 in A, and we've got 6 undecided, shall we say. So 30 plus 6, we're going to give our 36. I'll just write that fully. So we've got that, 30 plus 6. So basically, we're looking for that side of things, aren't we? But of course, the 20 is already counted within that. So what we need to do, we need to lose 20 off there. So we can do, just simple, 36, take away 20, and we will be left with 16. And that is how many we want. Okay. Now we've got a 4-mark question, and it tells us use Pythagoras theorem. So that's what we're going to do. Pythagoras theorem, we know a squared plus b squared equals c squared. And we need to find the value of x. So we need the longest side, which means we need the 2 shorter sides. So we need to know this side first. And to do that, I'm going to cover that up with my ID badge, because I can ignore that now for the time being, and I can just deal with this. It's still a right angle triangle, it's still Pythagoras, only this time they give us the longest side, and we've got one shorter side and we need the other shorter side. So we're doing the reverse. So we can do, so if I mark that off as these sides as A, B and C, remember the longest side is always C. I'm going to do the square of this minus the square of that to give me the square of that. So 17 squared, take away 15 squared, which is going to give me, again, we've got these calculators, let's use them. So 17 squared, take away 15 squared, and that leaves me with 64. And that's still the square of that side, so I now need to square root that. The square root of 64 is 8, so that means this side is 8 centimeters. So far, so good. Now, we've worked out that side, so we can now, again, thinking about with the ID badge, I can now ignore that triangle, because we've now got the 2 shorter sides, and I can work out the longer side. And we can go back to our a squared plus b squared equals c squared. So now we do, and let's tell you what, let's put the labels on them, a, b and c. So I can do 10 squared plus 8 squared. Let's clear that one off. 10 squared plus 8 squared, and that gives me 164. And again, I need to square root 164 to find the length of that. Okay. So all I do, again, I can retype it, or I can just do square root and then press answer, and that'll copy in my previous answer, the 164. And that gives me, again, gives me a third. I need to change that into a decimal. And we've got 12.8 6 and some more numbers. Okay, that's good enough for us, and that's in centimeters, because all it wanted us to do was to show that the value of x is between 12 and 13. We've got 12.8, 12 point something is between 12 and 13, so we're fine with that one. We can work with that. And then some straight line graphs to finish, or to do with straight line graphs I should say, because we're not actually needing to draw them. Yeah. What we can do there, when we talk about these, I'll write this down here. So we know the equation of the line is y equals mx plus c. M is our gradient and c is our intercept. So if we want a line that's parallel to y minus 5x equals 4, okay, all we do, we keep the gradient, and what we're doing then, we can just change the intercept, because the intercept will just move the line further up. So for instance, I'm just going to do y minus 5x equals 3. Basically all I've done is I've taken my line and I've moved it down 1 square, and that's all we're after. That's why it's only 1 mark, and then 1 mark again for this one. It has a gradient of 3. Now if it has a gradient of 3, that means m must be 3. So we can rule out this one, and we can rule out that one. And when we look at that, it passes through the point of 6, 15. Sorry, 13. What am I saying 15 for? Thinking of other things again. Now, what we're looking at now, if it's passing through there, we know that this point, this is our gradient of 3. So that means for every 1 this goes up by, this must go up by 3, because that's our gradient. So if that was 6, we do 6 times 3, we get 18. But of course 18 to 13, we've taken away 5, haven't we? And that's what we've got there. 3 times x minus 5. That one is just 3 times x. So that would have been, for that one would have been 6, 18 if it was just 3x. Okay. And that is that. And just to prove it, it even says, end of questions. Hopefully that's helped. And of course, anything you're not sure of still, and a rewatch of the video doesn't help, always ask your tutor. Okay. See you soon.